Hello everyone, I am Dr. Shumaila Hassan, Assistant Professor from the Department of Economics of the Bhopal School of Social Sciences. And today in this module, we are going to talk about a very important statistical test that we use to compare the means of two different groups and find out whether they are statistically different or same. Yes, I am talking about students' t-test. The agenda for today's module is, first we are going to discuss conceptually what exactly t-test is. Secondly, we will try and calculate the t-value. And third, we are going to run a t-test with the help of Excel. Now let us first see the story behind the development of t-test. The t-test was developed by William Seeley Gossett. Now William Seeley Gossett, hundreds of years ago, was employed as a brewer in the Guinness brewery. He developed this statistical test in order to test the differences between the yields of the barley fields. Now, he wanted to publish this particular research of his and he wanted to share it with the other statisticians. But the brewery was not in favor. They were not in favor of bringing out the secrets. But after a lot of deliberation and persuasion, they agreed to publish Seeley's work but under a pseudonym, that is student. So therefore, most popularly, this particular t-test is not known as Gossett t-test, but it is known as student's t-test. So let's first define what t-test means. T-test is a statistical test which is used to compare the means of two different groups as well as two samples from the same group. As and when we proceed with the module, you will be able to understand the difference between the groups and within the groups. T-test is a widely used statistical test in scientific researches as well as social science researches. So in order to understand the t-test better, let us take the example, a very cliché example of the barley fields. Let's say, for example, if I have two fields, field A and field B. Now for testing the yield of this field A and field B, I do not want to clear out the entire field. Rather, I would like to draw a sample from each field. So I take a sample A from first field and sample B from the second field. So here is the statistical representation of the distribution of the two samples that we have drawn, sample 1 and sample 2. By just looking at these two samples, they might seem to be equal. That means their means also are looking exactly equal. But whether these two are significantly different from each other, the yields are significantly different from each other or not, this we will be able to know only after we conduct a statistical test. And this is where a t-test comes in handy. So let us first understand what exactly a t-value is. The t-value is the ratio between the signal and the noise that we gain after completing our data collection. Now, what is signal and what is noise? How do we compute these two parameters? Let's see. Signals are the numbers that give me the difference between the two samples. The best way to find out the difference between two samples is to calculate their means and find out the difference. So therefore, the signal is calculated as the difference of means. The noise will tell me the numbers that are a hindrance in my interpretation. That means what is the degree of variability between sample A and sample B. And how do we calculate it? Signal upon noise, the ratio will be called as the t-value. We calculate it as the difference between the group means divided by the variability of the groups. Now let's first see the numerator. x1 bar minus x2 bar. Now what are these? x1 bar is the mean of sample A and x2 bar is the mean for sample B. Simple formula for arithmetic mean can be applied to calculate the mean for both the samples. Coming to the denominator will give you the variability of the groups. Now what is the meaning of variability? Here you can see the formula says S1 square divided by N1 plus S2 square divided by N2 and under root. So what is S1 and S2? S1 is the standard deviation of sample A and S2 is the standard deviation of sample B. What is standard deviation? Standard deviation gives you the dispersion that occurs in a particular data set. That means how varied is the distance between the mean and the data points. What is the degree of scatteredness of your data that you have collected? Lesser the degree of scatteredness, more the reliability of your data. And here N1 and N2 means the number of data points that you have in sample A, and N2 is the number of data points that you have for sample B. Now let's use an Excel sheet and see how easily can we calculate this t-value. These are the steps that you can follow to calculate the t-values that we require to compute the t-value with the help of the formula, that is signal upon noise. So step 1 is calculate the mean of sample A and sample B. Step 2, calculate the standard deviation of both the samples. Step 3, square the deviations, that is the standard deviation, because here we are not taking the standard deviation alone, but we are taking the variance, and variance is the square of standard deviation. Larger my variance, smaller would be my t-value. And why do we require a smaller t-value? That as and when we proceed with the module, you'll come to know. And the last one is put the values in the formula, that is signal upon noise, and calculate the t-value. So let's switch to an Excel sheet and see how easily can we calculate the t-value. So here we have the data in an Excel sheet. You can also use a spreadsheet if you want. So this is sample A and this is sample B. So these are the different yields that we have observed over the period of time. So first thing what we need to calculate is the mean for the data. So therefore, let's put the formula for average. So here is the average. So left bracket, select the data for which you want to calculate the average, close the parenthesis and enter. Now the same can be copied to the other cell just by dragging. So we've got the means for both the series. The next is to calculate the standard deviation. So again, putting the formula for standard deviation, put an equal to sign, standard deviation for sample and left parenthesis, select the data and close. So this is the standard deviation. Just to copy the formula, drag it to the right column. So here we have the standard deviation. But in the formula, we are not using the standard deviation, but we are using the variance. So therefore, for calculation of variance, again, we will have to see the second power of this particular value. So here I am raising it to the power 2 and again dragging it for sample B. Right. Number of data points that we have in the data set, that should be put an equal to sign, and with the help of count, you will be able to get how many number of data points are there. Bracket closed, enter. So 16 and 16 for both. So these are the values that we have, right. So these are the values that we need to put in our formula in order to get the t-value. Let's switch back. So we have the calculations done and we have the values that we need to put in the formula. But before putting the values in the formula and calculating the t-value, the first thing that we need to do is, in order to test the hypothesis, we need to spell out the hypothesis. Right. So this is what we have here. The HO, that is the null hypothesis, and H1, that is the alternative hypothesis for the problem at hand. So the HO says there is no statistically significant difference between the samples that we have drawn, and the H1 says there is a statistically significant difference between the samples that have been drawn. So how to test this hypothesis? We are just going to see with the help of t-value as well as the critical value. So here we have put the calculated values in the formula, and after the calculations, the t-value that we get is 2.3. So let's set aside this 2.3 and see what are we going to do next with this t-value. Our module is not about the t-value, but then our module is about the t-test. So let's see how are we going to test this hypothesis with the help of t-test. So the first significant step for calculation of t-value is over. Now the next step. Okay, here is the flowchart of what are the steps that you need to follow. The first was the calculation of the t-test. Now, the second thing is we need to have a critical value in order to compare it with the t-value. That is what is going to decide whether you are going to reject the null hypothesis or not reject the null hypothesis, right? So, the first thing is that you have to have a t-table at hand. Now, it looks a little complicated, but it is very easy to read a t-table. And what all things do we require to read a t-table here? So, the first thing is look for the probability. Now, probability that usually is taken for the statistical tests is 0.05. Now, what this p is equal to 0.05 means? The p is equal to 0.05 means that if at all we are drawing a sample 100 times, 95% of the times it is going to be the same result. And it is only doubtful that only 5% of the times we will be getting a different result, right? So, in this particular problem also, we have taken the p-value as 0.05. And how do we go ahead with reading this table? What is the next thing that we require? The next thing we require is the degree of freedom. Now, here is the degree of freedom written here in the table. And how do we calculate the degrees of freedom? How many independent values do you have, right, in a particular data set? That is the degree of freedom. So, in this case, the degree of freedom will be combined, that is n1 plus n2 minus 1. So, in our case, 16 was the value for both. So, 16 plus 16, that would be 32, and minus 2, that should be 30. So, for the row here, we are going to see 30, and for the column, we are going to see probability equal to p is equal to p-value is equal to 0.05. So, here if you can see, the value comes out to be 2.04, right. Now, this is the critical value that we have got, and we have to compare our t-value with the critical value that we have got from the t-table. Now, there is a rule of thumb to be followed. Now, what is that rule of thumb? Critical value you have calculated and it came out to be 2.04, right? And the hypothesis that you are testing is there is no statistically significant difference between the two samples. Now, the rule of thumb says that if at all your t-value is less than the critical value, you do not reject the null hypothesis. But your purpose here and your aim is to reject the null hypothesis, right? So, therefore, if your t-value is higher than your critical value, you are in a position to reject the null hypothesis. So, in our case, 2.3 is greater than 2.04, which says that we are in a situation to reject this null hypothesis. That means there is no statistical difference between the samples gets rejected, which means that there is statistical difference between the two groups and the differences are not because of chance. Here we have conducted an independent t-test or an unpaired sample t-test. Now, what does this mean? Independent sample t-test or unpaired sample t-test is a test where we are going to draw the samples from two different populations. The population here was the first Barley field and the second Barley field, and the sample that we had drawn was sample A from the first field and sample B from the second field. So, that means there is no connection between the data collected. Secondly, the two-tailed test, as we did not have any directional hypothesis. A two-tailed test would be carried when you are not in a position to define the direction of your hypothesis. That means you have not decided upon a directional hypothesis. Now, what does that mean? It means that there is a significant difference between the two groups, but then the direction is not defined. It can be more also, one can be more than the other, or the other can be less than the other. So, therefore, you do not have a set direction for your hypothesis, and that is the only reason when you do not know the direction of your hypothesis, that is the time where you conduct a two-tailed test, right? And in this case, either the null hypothesis said that there is no difference. So, that means no difference means both the means are same. That means x1 bar is equal to x2 bar. But when you say that there is a significant difference between the two groups, it could be greater than or less than. So, therefore, we had not defined the direction of our hypothesis, and that is the reason we conducted a two-tailed test. Now, this is where we have put in the formula manually and calculated the t-value. But then here the magic of the Excel sheet works. It helps you to directly calculate the t-value. Let us see how. So, here we have again come to our Excel sheet where we have the data. So, here Excel gives you an provision of directly calculating. Let us write t-test first. So this would be t-value, and here put an equal to sign and t-test. So double click, open the parenthesis. So array 1. So this is my array 1, comma, array 2, comma, two-tailed distribution, and again it's a paired 2, comma 2. So the t-value, or we can call it as the probability value of our test, comes out to be 0.02. Now this you are not going to compare with the critical value, but this particular thing, what you have got here, will be compared against 0.05, which is our probability value. So therefore, if you get the t-value or the probability value here less than 0.05, in this case again you are in a situation to reject the null hypothesis. So the rejection region and the acceptance region, with the help of a bell curve, you can understand it this way, that these are the tails of the bell curve or the distribution, right? So 0.05 lies here, and 0.05 will be divided into two parts. That means because our hypothesis was not directional, so in that case we have conducted a two-tailed test. So 0.025 here and 0.025 here, and this is the 95% of your acceptance region. So if your value lies here, it is going to be not rejected, but if your value lies here, we are in a situation to reject the null hypothesis. There are certain assumptions that are required for carrying out a t-test. So the first one is that the distribution of the data should be normal, and the next is that the variance of these two samples should be almost same. That means the variance should not be very varied between the two samples. Next is that the data points should be roughly same in the two samples. Here we had equal data points in both the sets, as well as in the last one, it is not advised to use a t-test for a sample greater than 30. So if you have the values between 20 to 30, it is advisable to use the student's t-test. Right. So in our next module, we are going to talk about the paired sample t-test. So stay tuned and thank you.